Hello, good day to you. Welcome to this introductory lesson on the C++ programming language. Okay, and I believe we're gonna have so much time together and so much fun in these classes and set of classes. I am Timothy Onogu by name, and I'm going to be your instructor for this set of lessons. And the C++ is actually a very nice language and very sweet. Okay, so we're gonna start from the basics to the intermediate level to some little, just quite a number of advanced things, such that so it's applicable to you who have no idea of programming, or you who have been programming in the language before, or if you're just a hobbyist or professionalist. You're gonna learn so much here that you can apply to your field. Okay, so starting with this, I think I have some set of slides. Not think, I know I have some set of slides. So let me fire up my Office or my presenter software. Okay, now this is a KDE desktop environment of the Linux operating system. Now this is Kubuntu. The name of this operating system or distro is Kubuntu Linux. Now Linux is another operating system. If you haven't heard of it, well, it's quite okay that you might not have heard of it. Believe me, I've come across with some people who have been using computers for almost 4 years, 5 years. They've probably never heard of Linux. Okay, now Linux is a powerful system. It's a powerful set of operating system that, well, it's not a set of operating system, but it's an operating system with so much set of tools that makes it so usable in the industrial field. Okay, now this KDE desktop environment was built with C++. Now, going to this slide, we have something here to start with. Okay, so here are the goals, and now among the goals here is to teach you every basic idea on programming and computer architecture. How does programming relate with computer architecture? How do you map those knowledge together? How do you really instruct systems? You see, we're going to delve into the programming aspect and the translation from your high level language to your low level language. Okay, how do you use C++ to really um, control devices, to really write programs, GUI interface, okay, that's graphical user interface, and so many things. Okay, now I have another goal here, which is to teach you the C++ programming language. Duh, why did you sign up for this class? Most likely that's the reason. Okay, now specifically the C++ 11, which is the latest standardized version as of the time of this screencast. Now this standard, it's really a major improvement over the language. C++ came in so many years ago, and this standard is so good and so usable for the beginner to the advanced level. It adds so much interface and so much feature to the language, not interface, sorry. Okay, now to teach you algorithm design, implementation, and several known algorithms, right? Now, I think from English context, you don't have S there, so obviously you're just saying algorithm. Now, programming is backed by algorithm. You really can't write programs without algorithm. We're gonna go over what algorithm is, which I'll definitely give you an example now. Sorry, a definition now. An algorithm is the very finite each step of or sequence of instruction given to a computer to solve a problem. Okay, now our next goal here is to teach you programming patterns, introduce you to software design and engineering. Now some professionals argue that software engineering doesn't really work. Some do. Well, on the long run, you really have to know so much theories and so many things to get you starting and to get you into the work field. Okay, you can't really program in the real world without so much of these theories. Now we're going to use these skills in the first four goals that I've mentioned so far. We're going to use the skills we've acquired there to build and implement a few basic and small software from scratch. Now those goals include a word jigsaw game, a simple drawing program, a simple text editor, and a simple web server and client. Wow, I love this point, this fourth one. Okay, now a basic physics simulation program. We're gonna use math theory and so many math knowledge that you've had in your high school. I'm gonna assume that you have some high school knowledge of maths, even if you're a high school student. I'm gonna assume that you have some basics there. Now, as a bonus to this set of tutorials we're gonna go through, I'm gonna give you head start knowledge on mapping your C++ knowledge to Python programming. Python is actually one heck of a sweet language, right? We're gonna go through them. Python is actually an interpreted language, but it so much helps in your workflow. Now, introduction to testing, we're gonna see what testing is all about. How do you test your softwares and different testing, black box, white box, unit testing, whatever, so many of them. Now, we're going to also go into automated testing using Python. Well, automation, simple. We can just have some little program that we do, and we just want to test some few scenarios or some few use cases. We use Python to generate some sample use cases and feed it into the program to see whether it gives us correct output for everything we do. Okay, we're gonna go into auto-generated codes. Now, some games that you actually play, some portions of the codes were not written by human being. It was auto-generated by computers. Now, what is programming? Programming is the only language that exists between humans and computers. Okay, you really can't instruct a computer without having some defined set of programs to it that will know how does it take your instruction. Just as if you're a human being, you're learning, you're growing up, you're learning to take instructions, such that if I instruct you to, hey, get me a glass of water, you know what to do. Okay, now programming gets to that level. That's high level. Now, it's a sequence of explicit instructions given to a processor. Well, a system or whatever you're dealing with, it all boils down to something that processes it. It's a processor. Okay, so now that's the next thing about this. Now, the next thing is that it's a brain developing endeavor. You cannot have interest in this without you obviously being a very smart person. Okay, for you to have developed interest in this, I definitely sure that you're one heck of a smart person. Now, the next thing I'm going to say is this, that it's a daredevil's task. What do I mean by daredevil? Let me see if I bring up a dictionary here. Okay, so we see that it's something that will, I just say, you're gonna require passion, so much passion and so much drive to keep the fire burning. Just as if you keep light fire, set fire in the bush or something on an object, you really need fuel to keep it going. So you're going to need a lot of passion, and your fuel in this case is passion and some drive. And there's a lot more definition to it. These are some head start to help you go. Okay. Now, the next thing is that what is the C++ itself? Now, the C++ was invented by Professor James Strastrup in 1983. Okay, so you can see that it's actually a very matured language. It's been here for decades now, like 3 decades now. So now, it was invented by this man in I think AT&T Labs or Bell's laboratory. Okay, and it's since then it has grown so much to be widely accepted. Now the next point is that it's a nice and totally unambiguous language that is easily written. These are some of the strengths of the C++ that makes it widely adopted by the industry today. It's a multi-paradigm programming language, a tool for building artilleries. What do I mean by artillery? I mean like real-time softwares that you do not expect lagging or any sort of failure in them. Okay, it's a strongly typed language. It's a multi-level language, an industrial strength language. Now, this point here, and this point here, and this point here is uh, it's actually some means that you could use to categorize languages. You have some functional paradigms, you have procedural, object oriented, and you have so many of them. We're gonna go over through them. I'm gonna explain some of them to you. C++ adopts so many of this. Now, it's a strongly typed language. It's a multi-level. Well, maybe you just can't say that we have the high level, the low level. So now the next thing is, what is the language model of the C++? Okay, there are things that the language, you will like divide them into two portions. You have the core language, which consists of the syntax, the keywords, semantics, and other things attached to it. The core language is actually how you represent what exactly you want into the language, and a compiler collection is what will translate your language to some form of intermediate language or to your machine level language that it can execute, and it also gives it some form of introspection that your operating system can load your program into the memory and actually pass it to the processor and give it time. You see, we're gonna go through some technical stuff like this. If you don't understand it, don't worry, I promise you you're gonna understand. I'm gonna give you so many analogies to real life situation. Now, library. Now, the library part of the C++ is analogous to the library you know in academic environment, right? Where you go and you read books and you have things to help you do one or two things. Now, the C++ default library you have, it's called the Standard Template Library, the STL. Standard because it's standardized by the ISO committee, template because you can put virtually anything inside, and library, well, you just know. Okay, now you have the external or cooperating library. These are the libraries that your program cannot really do without. Okay, you may have to interface with the driver, you may have to interface with something, so you really have to play around with interfacing your program with other libraries or using other libraries in your program. Okay, now the next thing is some unavoidable stuff, which includes operating system specifics. Okay, there's some things that are actually peculiar to operating systems. One operating system that is not to the other. For example, this operating system I'm using, the way its paths are actually written is different from Windows. You're going to go through some basics of integrated development environments, which is the easiest way to get started with programming. Okay, it's gonna give you code completion, syntax highlighting. I'm gonna go through over there, and you're going to have source code management systems. In the long run, you'll find out that you can't easily just be writing and saving your programs and expect things to just flow like that in larger programs. It doesn't really work. So this is a simple C++ program snippet. We're gonna go through this. We're gonna start with this, something like this, and we're gonna end up writing more complex snippets like this. Now, this snippet was actually taken out of one of my programs that I was writing. Okay, now getting started, you have the compiler collection. This is what is responsible for translating the code that we are going to write into machine readable format. The compilers we have the Microsoft Visual C++ compiler Windows. If you're actually running Windows, this is actually a very powerful compiler to use. We have the GNU compilers. This GNU is a recursive acronym standing for GNU is not Unix. GNU is not Unix. It's goes on like that. Now, Ming is actually minimalist GNU for Windows. It's a compiler made by these guys so that you can actually write open source softwares that, well, it is a set of compilers. Now, this GCC G++ is actually specific to Linux, Mac OS. This G++ command, actually, this G++ you have it on Windows too, but it's given by this Ming. Okay, now you have a lot more different types of compilers. You even have the Intel compiler. For more, refer to Strostrup, the inventor of C++. Refer to this link. You see several compilers. Even if you're going to do embedded system programming, you want to program some little chips, this is going to be applicable to you. integrated development environments, you have the Microsoft Visual Studio, the Express or Professional. The Express is actually free. Professional is actually for something so much bigger, so much bigger. Now, Express is what you are advised to start with. You have the code blocks. Now the code blocks is what I think we're going to primarily use in this. You have the Xcode. This is specifically for the Mac OS users. The Qt Creator. We're going to use this Qt for GUIs. Actually, we're going to learn from this and a lot more. There are different types of IDE to use. Okay, so once again, thank you for watching this, and really hope you do have a nice time. Okay, so thank you and quit.